Good morning, my online trigonometry class. This is a little update on where you should be right now with sections 1.3 and 1.4 and what to be thinking about this week. You have an upcoming quiz on Monday, so I wanted to give you guys a heads up on some important things to know about sections 1.3 and 1.4. So, section 1.3 introduces the idea of a trig function. You have six of them, and they're all based on the values of x, y, and r. So, what do I mean by x, y, and r? You've never really dealt before with functions quite like these. So you have x, y, and r. Where do they come from? What am I talking about? Well, let's do this. I'm going to try to draw a xy coordinate plane, and let's talk about what x, y, and r would appear as on a coordinate plane. So what we have here is the x-axis, and that is referring to your x in my list there, and the y-axis, that's your y, and the r, what's r? Well, it's a radius. So let's do this. Let's go over 1, 2, 3 here. Okay, so suppose that our x was 3. Let's go to y is 2. Okay, so if I place an ordered pair here, this would be x is 3, y is 2. So what I'm just going to do here is I'm going to write my ordered pair of 3, 2, understanding that the first of the ordered pair is x and the second is y. Now here's the interesting thing is I'm going to now connect from the origin, I'm going to connect a ray that goes through my ordered pair. Okay, so I'm trying to make a straight line there. And that would be my radius r. That means that this point right here is on a circle. So what I'm just going to do is I'm just going to kind of do as best I can. It's a little bit sloppy, but whatever. I'm just going to come around like this and close up a circle, okay? So what I see is that I've got a circle, I've got an ordered pair, 3 comma 2, and therefore what would be the r value? What is the r value? Well, you have to calculate it. And it comes from the Pythagorean theorem. And the Pythagorean theorem in this picture here would be actually x squared plus y squared equals r squared. So notice here that if I close up this as a right triangle, so if you look at this as a right triangle, so I'm just going to sort of highlight that right triangle there. If this is the right angle, notice that your r value, your r is the hypotenuse, the x is a leg, and the y is a leg. Okay, so that's why it's x squared plus y squared equals r squared. It's something that you're going to do again and again and again in this class is the Pythagorean theorem, and x squared plus y squared equals r squared is the relationship between x, y, and r. So let's figure out what that r is. So we would have 9 plus 4 equals r squared, and so you have 13 is r squared, and so you have the square root of 13 is r. Notice that r is radius, and you would never say that the radius is negative. So now what I have is 3 values as promised here. Everything in trig is based on these 3 values. And so what you have is x is 3, y is 2, r is the square root of 13. Now the important thing is this, to realize that from these 3 values you get 6 trig functions, and that's introduced in section 1.3. And I'm just going to here point out to you that this table right here is something that you need to know very well. That is, you have to memorize it. So this is in section 1.3, and the table is your first introduction to what is sine, what is cosine, what is tangent, what is cotangent, what is secant and cosecant. So notice over here, if you come over here to this column right here, what we have is a definition. And so I'm just going to try and zoom in here. And what you have is a definition of each of the six trig functions. Notice that either x, y, or r is in the ratio. So you have, in this case, y over r. This one doesn't involve x. This is sine. Sine of theta, we write it this way. We say it out loud, the sine of theta, but we write it symbolically as sin with a theta. Sine of theta equals, and this is its definition. It's a combination of y and r as a ratio. Cosine defined as x and r as a ratio. Tangent is y over x as a ratio. So I'm going to pause here and I'm going to suggest that you have a look at cotangent secant and so a cosecant and have a look at their definitions. And I want you to observe that they are simply the reciprocal of sine, cosine, and tangent. So what would happen if you took the reciprocal of y over r? If you took the reciprocal of y over r, that means you flip it over, it would be r over y. So notice that the reciprocal of sine is cosecant. Okay, so that's down here. Do you see r over y is the reciprocal of y over r? Therefore, what we say is that sine and cosecant are reciprocal functions. So you will also in section 1.4 be introduced to the reciprocal functions and how we deal with that. But I'm just pointing that out to you right here, that the main functions in this class are sine, cosine, and tangent. And they are defined over here respectively that way. And then down here you have your other three functions which are reciprocal functions of the first three. Notice that cotangent is the reciprocal of tangent, and you also have that secant is the reciprocal of cosine. So I'm hoping that you guys can see that and observe that. Let me erase this because this is a little bit, yeah, blocking that. All right. Now, how do we deal with this? Let me zoom back out here. How do we deal with this and work with this? So let's go back to our original statements up here and let's look at sine of theta. So if we have sine of theta, think about what the value of sine of theta would be. So sine of theta by definition is y over r. Have a look at your list here and notice that your y is 2. So just go ahead and replace the y with a 2, and the r is the square root of 13. Okay, so this is the value of sine of theta. This function is never written without theta, by the way, and so you just say sine of theta equals 2 over the square root of 13. But now think about this. We never leave the denominator with a square root, so the next step is to what we call rationalize the denominator. And that's what I'm doing right here. You always just multiply top and bottom by the square root that appears in the denominator. And therefore, what we get is 2 square root of 13 over, sorry, that was kind of sloppy. Let me go back and erase that. And yeah, okay. So we get 2 square root of 13. And this is over what? So square root of 13 times square root of 13 is always just then 13. Okay, so this is the value of sine of theta in the end. This is the final, most simplified value that we claim. This is based on choosing the point 3, 2. 3, 2 has this as its respective value of sine, if that makes sense. Okay, let's talk about cosine. So similarly, we have to get our definition memorized, and this is x over r. So you just have to know that. This is how it's defined. And then you go to your values up here and notice that what we have is x is 3 and r is the square root of 13. Right, now Again, you have to multiply top and bottom by the square root of 13 to rationalize the denominator. This is really customary to rationalize denominators, so practice doing that, and we get 3 root 13 over 13. We never use our calculators for this. You do the work by hand, and everything can be done without a calculator at this stage. Okay, let's look at tangent. So tan theta. Now, if you look at your definitions, this is y over x. Okay, so look at your values of y and x, and this is quite simply 2/3. Done. All right. Okay, so I did point out, let's have a look again. Let's point out there are then the other three, cotangent, secant, and cosecant. It is easiest if you get the reciprocal functions memorized, okay? So sine of theta is y over r, and like we were just talking about before, it has a reciprocal function, and that would be cosecant, and you symbolically write, so cosecant of theta like so, and this is r over y. Okay, let's look at what you said was sine of theta. Okay, so I'm going to go back over there to the right-hand side there. We already made a statement that sine of theta equals, I want you to first notice the value where we did not rationalize the denominator. Okay, what would happen if you took the reciprocal of this value, 2 over the square root of 13? You know what? You would get the value of cosecant. Because look how you're supposed to just flip over the fraction. So I take the reciprocal, the bottom becomes the top becomes the bottom. And notice how if I use this, then the square root is in the numerator, which is preferable. All right? So there we have now the value of cosecant. Understanding that if you want to tell me what the value of sine of theta is, it's better if you give it to me as the rationalized version, 2 root 13 over 13. But when I went to find the value of cosecant, I wanted to flip over this one so that the square root was in the numerator. Let's go to cosine now, and let's identify what its reciprocal is. And again, I'm just going to go to the one where we hadn't rationalized the denominator. Now, secant is the reciprocal of cosine. And so if I want to know the value of secant, I can look back at the value of cosine. And I just flip it over as a reciprocal. And there I have it. That is my value of secant of theta. It is square root of 13 over 3. And finally, we already claimed the value of tan of theta. It's 2/3. Okay, so if I took 2/3 and I identify the reciprocal function as cotangent, then I just flip it over. I have that cotangent of theta is 3/2. Okay, now I have all 6 of my trig functions stated. Notice that they are all based on just knowing an ordered pair in an xy coordinate plane. Here's the r value obtained, okay, by doing x squared plus y squared equals r squared. Once you know x, y, and r and the definitions of all your 6 trig functions, you can always give me the values of all of the 6 trig functions. All right, so that was section 1.3. It's just being able to deal with x, y, and r and the definitions to know the 6 trig functions. Okay, let's turn to section 1.4. In section 1.4, we have the formal reciprocal functions here in table 1. Notice that what we have here are 6 statements of equality. And these statements of equality discuss and refer to the reciprocal nature of cosecant, secant, and cotangent back to sine, cosine, and sine, cosine, and tangent. Okay, so let's look. If sine of theta equals y over r. And if I go 1 over, okay, so this means I'm taking the reciprocal.